right, today what we're going to do is we're going to look at section 2 in chapter 9 or chapter 11. Again, mainly what we're looking at is we're looking at perimeter and we're looking at area of different figures. Last section we looked at triangles and parallelograms. Today what we're going to look at is trapezoid, rhombuses, and kites. So taking back some information that we learned about what a trapezoid was, what a rhombus was, and what a kite is, and now what we're going to do is we're going to apply some of that. So let's first of all take a look at the area of a trapezoid. The area of a trapezoid is half the product of the height and the sum of the lengths of the bases. And so what does that mean? Well, it means this. So the area is 1/2 the height, parentheses, base 1 plus base 2. Now, the order in which you add base 1 or base 2, it really doesn't matter. If you take a look at the picture, you're going to notice that the top they have is base 1, the bottom they have is base 2. Again, it doesn't matter what you label the base, but know that when we do the bases are the ones that are parallel to each other. The height of it, be careful, because a lot of students want the legs to be the height, but in reality, the height is just the piece that comes straight down and forms that right angle. So it's very similar to what we did with the triangle. So let's take a look at an example like this. Now, you're going to notice that this trapezoid, when I look at what's parallel, it's this side and this side. So if you need to move your paper so that the parallel sides are on the top and the bottom, feel free to do that. That might actually be easier. I'm not going to do it. I'm going to just take it the way it is. Again, there are 3 steps. So the first step is writing down the formula. Area is 1/2 the height, parentheses B1 plus B2. The second step then is to add what I know. And they're asking you to find the area. So I'm going to leave the A. I'm going to grab 1/2. And now you can see that my height is going to be my 5. And I know that because of this little right angle here or this right angle here, I know that that is the height. Base 1, doesn't matter what I call it. Is it going to be 6? Is it going to be 9? It doesn't matter. I'm going to put 6 and then I'm going to put 9. And again, those I know are the bases because they're parallel to each other. And then the third step is going to be following this through. Now this actually has more steps than one step. Area equals 1/2, 5, and then 6 plus 9 is 15. And then I'm going to bring that through. So I end up with 37.5 or 1/2, and it would be units, and it's squared. And the reason why it's units squared is because it's area. All right, let's go ahead and let's move on to the next shape. This shape you're also going to notice is a trapezoid. Again, take a look at the parts that are parallel to each other. So this is parallel to this, so that would be B1 and B2. So I'm going to go ahead and I'm going to come over here. I'm going to write the formula. A equals 1/2 H B1 plus B2. So that's the first step. The second step is going ahead and then grabbing my measures. Okay, and you're going to notice here that the height is straight down. Like this is not the height on this side and this side is not the height. The actual height of the figure is this right here, and it dropped down to make that 90-degree angle. So I'm going to write in 7.5. Notice how I'm using parentheses. I'm not doing an X in there because that looks like a variable, or a dot because that could look like a decimal. And then I'm going to grab my base 1, which is 6, and my base 2, which is 12. And again, it doesn't matter which is which. I'm going to go ahead and bring this through. Add those together, I get 18. And I go ahead and multiply it through, and I get 67.5, and that's going to be centimeters squared. Again, I'm finding the area, so I'm going to include the squared. All right, let's take a look at this next figure. You're going to notice this next figure. Again, I got base 1, I got base 2. But you're going to notice that I have no measure here, I have no measure here, and I don't even have a height. So that's going to cause a bit of a problem, but let's go ahead and let's grab the formula. I know it's a trapezoid, so A equals 1/2 H B1 plus B2, area equals 1/2. You're going to notice on this one, I don't have the height. I do have the base. So one base is 7 and the other base is 10. Again, 7 is from here to here. 10 is from here to here. Now, we've got a little bit of a problem because I don't have the H, and that is something that I need. But you will notice that I have a 45-degree angle and I have a right angle here. So this tells me that I can do the 45, 45, 90, or I can do trig. Either way is fine. You'll get the same answer. Another way of doing it is if this is 7 and this is also 7, because that looks like a rectangle with that right angle, I know that if I take 10 and I subtract 7, I get 3. So because I know that, I don't even need to use trig on this. I can say that this length right here is 3. It's a 45, 45, 90, so I know that that's an isosceles triangle. So this is also 3. So I'm taking a look at the properties of an isosceles triangle of 45, 45, 90. So my height then is 3. Area equals 1/2. I'm going to grab 3, and this is 17. And the area ends up giving me 25.5, and it's centimeters squared. Again, remember a 45, 45, 90, if we looked at it, if I know this is 45 and this is 45, I know that this side and this side are congruent. So there's kind of a little throwback to those special triangles. All right, let's keep going. This one, again, is a little bit different. I'm going to go ahead and say, okay, I've got a parallel line here, parallel line here. I know it's a trapezoid. I'm going to go area equals 1/2 H. B1 plus B2, area equals 1/2. Okay, I'm taking a look at the picture. I don't know my height. I'm going to put that here. I've got base 1, which is 16, base 2, which is 12. So I'm going to leave the H for just a minute. I'm going to go 12 plus 16. And I need to find my height. That's a problem, okay? And I can't do it but like before because I don't, that triangle is a 30, 60, 90. And that isn't an isosceles triangle. So one way of handling this is I can use trig. So I'm going to take 60 degrees, okay, and I know that this piece right here is 12, and I know that 16 minus 12 is 4, so this piece is 4. So I'm going to grab 4 is adjacent to 60 and H is opposite to 60. So opposite and adjacent would be tangent. The opposite of H and the adjacent is 4. Multiply both sides by 4. 4 tangent 60 equals H. H ends up giving me, I have 6.93 approximately. When you put it in your calculator, please make sure that that is nice and large. Don't cut it out. You can round it when you're writing it down, but again, keep it large when you're in your calculator. So I'm going to go ahead and I'm going to put in my formula 6.93. Area equals 1/2. 6.93 times 28. So my area is 96.99 inches squared. So again, we're going back to trig, and we're going back and looking at, the SOHCAHTOA. You might need to go back and review that a little bit. Again, tangent, I can write it here. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent next to and hypotenuse over hypotenuse. And tangent is opposite over adjacent. So that's what you need to set up. You might need to go back and review a little bit. If you need some help, let me know. But that is the trapezoid. Now what we're going to do is going to move on and we're going to look at a rhombus. Okay, a rhombus, remember, is kind of like a lazy square. And it's asking me to draw in the diagonals and then take a look at the pictures of them and how they relate to one another. So if I look at a rhombus or the lazy square, the diagonals here and the diagonals here, okay? And if you remember back, I know it's a rhombus because all sides are congruent. I also know that the diagonals of the rhombus are perpendicular, and I know that they bisect each other. So that is something you'll need to review about a rhombus. The other picture here is a kite. And so to take a look at this, I'm going to draw in my diagonals. They are 90 degrees. I know that this side of the kite is congruent to this side. This side is congruent to this side. And I know that this diagonal is cut in half. Notice the other diagonal is not cut in half. You can look at it and notice that it is not. One other thing you can bring together is that this angle is congruent to this angle. That's another thing that you can look at when looking at a kite. Okay, so let's go ahead and go down, and the area for both of them is area equals 1/2 D1 D2. The D stands for diagonals. Okay, so let's go ahead and let's take a look at each one of these figures. So here's the first one. It asked me to find the area. I'm going to go ahead and I'm going to grab that formula. A equals 1/2 D1 D2. And if I look at this figure, okay, I know that this side is congruent to this side. I know this is 90 degrees. I know that this is congruent to that. Okay, you're going to notice outside they give you one of the diagonals. The diagonal is 3 and then 8.2. So I'm going to go ahead and I'm going to go area equals 1/2. D1 would be 3 plus 8.2. And again, it doesn't matter what you call diagonal 1 or diagonal 2. Okay, what we need to do next, though, is we need to find this diagonal. And I know that the diagonal was cut into 2 pieces. I know that it's a 90-degree angle. And I know that this piece right here, this is 3. And I know that because of this 3 out here. So what I'm going to do is I'm going to pull out this triangle right here to try to find the base of the triangle. So I'm going to pull it out. I'm going to bring it down here. This is 3. This is 4.39. And I'm going to call this M. So to find M, we're going to use the Pythagorean theorem. Because remember, that's one of our go-to things. So I'm going to go M squared plus 3 squared equals 4.39 squared. And 4.39 is the hypotenuse. So I'm going to go M squared plus 9 equals 19.2721. And again, you don't want to chop that off too soon. M squared gives me 10.272. I'm going to square root it, and M ends up giving me 3.21. So what M gives me is it gives me the one side of the diagonal. So this would be considered M, and this would be considered M. So I'm going to go over here, and I'm going to take that 3.21 plus 3.21, which is the 2 diagonals. And then what I'm going to do is I'm going to bring it together. So area equals 1/2. I have 11.2 times 6.42. Area ends up giving me 35.95, and it's inches squared. And again, you want to be really careful not to chop off those numbers too soon, because that could cause a change in your answer. So make sure that you're checking your answers as you go. Make sure you're not chopping off numbers in your calculator. All right, let's go ahead and let's look at this rhombus. Again, my area formula, A equals 1/2 D1 times D2. Area gives me 1/2. One of my diagonals is 10. They gave that to me. And the other one, you're going to notice they gave me half of it. This is 3.5, and the other would be double it. So I'd go 3.5 plus 3.5. So the area equals 1/2. 10 times 7. Area ends up giving me 35. And that will be centimeters squared. So with this one, you can see it's a lot easier. It's kind of short and sweet, and it gives you the answer that you need. All right, and then finally, what we're going to do is we're going to come down and we're going to do the last one. This shape, again, is a trapezoid. So I'm going to go ahead and grab my trapezoid formula. A equals 1/2 H, parentheses B1 plus B2. Okay, and you notice that they gave me the area. So I'm going to grab 88. My advice to you is not put meters square. You don't need the label right now, so just leave all the labels off until you get to the very end of the problem. I'm going to grab 12, and you're going to notice that they give me a lot of numbers. You're going to notice that they gave me a 12 and they gave me an 11. When I'm looking at the height, I'm going to look at the 11 because, again, I've got that right angle associated with that. So I'm going to grab the 11. Base 1, 9. Base 2, it looks like X. So that's what I'm going to try to find. So I'm going to go ahead and I'm going to tighten this up a bit. There's multiple ways of doing it. I think what I'm going to do is 1/2 of 11 is 55, or 5.5, I'm sorry. 9 plus X. Okay, and then what I can do is I can distribute. So 88 equals 49.5 plus 5.5 X. I'm going to subtract the 49.5, and I get 38.5 equals 5.5X. If I divide by 5, then X ends up giving me 7. And it would be just meters. And the reason why it's just meters is because that is the base. I'm not finding the area, I'm just finding the base. So today what we did was we found the area of a trapezoid, of a kite, and of a rhombus. So if I were you, what I would do is I would take a sheet of paper and I would write down the shapes from yesterday and the formulas, and I'd add these formulas to today and label it 11.2 and have it in front of you as you're solving your problems. If you have any problems, make sure that you contact me.